In this video, I'm going to solve a problem on signal to noise ratio, this problem number 1 here. And so I hope this helps as you watch. What we're given is the signal power and the noise power, and they're both given in dBm units. We are asked to find the signal to noise ratio. We're asked to convert both of those powers into milliwatt units. And then we're asked to calculate the signal-to-noise ratio as a ratio where we're taking signal and noise in milliwatt units. Finally, we're asked to take this ratio from part C and convert it into dB units and verify that it agrees with the ratio we get up here in part A. So this is a typical problem verifying that no matter how you do the units, it all works out. Okay, so the signal-to-noise ratio is in decibel units. The signal power in dB units minus the noise power in dB units. And if we plug into this equation, then we get 24 minus -3, or 27 dB of signal-to-noise ratio. And sometimes in our loss budgeting, we plot the signal and the noise on a vertical decibel scale, and 0 happens to be here, but this is then the signal-to-noise ratio. Okay, it's the distance between the signal and the noise on that vertical decibel scale. And that's the nice thing about decibels, is we can just make a number line like this. Okay, now I'm going to convert both of these into milliwatt units. Okay, so the signal into milliwatt units is, let's see, to go back into milliwatts, we have to take 10 raised to the power of the signal, 24 dBm over 10. And I know that what this is going to be, because this is 24 dB is 24 is 0 plus 10 plus 10 plus 10 minus 3 minus 3. So 24 is 30 minus 6. And 30 dBm, let's just take it as a ratio, is a 1,000. Subtract 3 takes us, so we have times 10 times 10. We have 1 times 10 times 10 times 10, which is 1,000, minus 3, which takes us down to 500, dividing by 2. Dividing by 2 again is 250. So this is going to come out to be 250 milliwatts. If you do it on your calculator, you'll get something very close to that. The noise power in milliwatts is 10 to the minus 3 over 10. And this we also know, -3 is 0 minus 3, which starts us off at 1 in decibel units. Minus 3 takes us to 0.5. So this is going to be 0.5 milliwatts. Do it on your calculator, you'll get something very close to that. And now what we're going to do is we're going to calculate the signal-to-noise ratio, the ratio S divided by N, where they're both in milliwatt units. So the ratio S by N, which is really the signal-to-noise ratio as a ratio in linear units, is 250 milliwatts divided by 0.5 milliwatts. And this we know is a ratio of 500. So this is the SNR in linear units, or in other words, as a ratio. Finally, what we're going to do is take this ratio and convert it into decibel units, and I certainly hope we get 27, and it turns out we will. SNR in decibel units is 10 log base 10 of the SNR as a ratio. So this is 10 log base 10 of 500. And it turns out, again, we can do this using the rules of tens and the rules of threes. We say that 500 is 1,000 divided by 2. And so we had 30 decibels minus 3. The 1000 is the 30 decibels. Dividing by 2 is subtracting 3, and I get 27 dB. And again, I recommend you type this in on your calculator to make sure that you get 27 dB. And so no matter how you do the problem, whether you do it in decibel units the whole way, you start in decibel units and you make your calculation in decibel units. You can also convert everything over to linear units and then convert back into decibel units, and you'll get the same answer. Okay? Hope this helps on this problem, and thanks for watching and listening.